Okay. Yeah, let's see. I mean, for this one, right? For the cubic term, if we do y plus t, right? Y plus delta, right? We're adding some offset, and will be the cubic, right? So can you tell me what is the square term, Jonathan? I think Sam already know it. What is the square term, Jonathan?
3a.
3, pick one, right? It's a 3a. Then what?
Y squared.
You have y squared term, and what's the other term?
That weird thing.
It's delta, right? So
Yeah,
basically, yeah, basically, I mean, you can see for this one, we have a term like the 3a, right? We have the delta square of the y, right? And
what is
then
delta?
that's a kind of replacement. I want to say, for example, x equal to y plus some delta. Is that okay? I want to do a replacement. For example, b equal y, bx equal y plus delta of the square, right? Can I do this, Jonathan? No problem, right? Do you agree with me, Jonathan?
Yeah.
I can do this, right? Okay. Now let's see. This is the so this. What happened? Hello?
We expand that one as well.
Okay, good. Yeah. Jonathan, are you there? Okay, let's expand here,
Yeah.
right? So what we can do is we can do the b of the y square, right? Plus the 2b delta of the y, right? And then we can plus the b of the delta square, right? So you can see how can we cancel it? What kind of delta we need to set help us to cancel it, Jonathan or Sam? Delta equal negative of what?
We need to cancel the y squared term. So 3a delta plus b is equal to 0.
We need to set delta equal this, right? Okay, so now let's do it. Okay, so let's replace delta with this number. Okay, so we have the a to the y of the cube. Then we don't have this one, right? Then we plus 3a, right, times the b square over 9a square, then plus of the 2b, then negative b of the 3a of the y. Okay, then we have this term. I'm sorry, we have more terms. Let me. Okay, now we have we have the term from the c, right? Then we plus c of the negative b of the 3a. Then that's all the y terms. Okay, then let's add in the constant term. The constant term will be a. Then we have negative b cube to the 27a cube plus b of the delta square is b square of the 9a square plus c times delta is negative b of 3a, then plus d equals 0. Any questions so far? No problem, right? Jonathan, are you listening?
Yeah.
Okay. Any questions,
you want
Jonathan?
to make it depressed.
Okay, I want to make it depressed. Now, how to can we do it to the standard format? we want to monatomic, right? That means we want the cube coefficient to be 1. Then what we do is y cube plus, okay? We can divide by a, right? So what is that? Let's do a common denominator, okay? So 9a of the cube. Then we have the 3ab square minus, this is the 9a square minus the 2b square times 3a. Then we minus the bc times the 3a. Then it's of the y. Then we add the last term is we have the 27a cube. Then we have negative ab cube, then times 3a plus 3a of the b cube. Then we times 9a squared minus 9a squared bc plus we have 27a cube of the d equals 0. So now you can see any kind of the general of the cubic form can be reduced to the depressed form with p equal 9a cube 3ab squared minus the 6ab squared is negative 3ab squared, then plus minus 3abc. Okay, and the q equals to 27 of the a cube. Then we can okay, there are some term we can cancel. It's the square. Then negative b of the a, okay, plus 2 of the b cube, then minus 9abc, then plus the 27 of the a squared d. Okay, so by setting the p and the q equal this, with any general of the cubic term can be reduced to the depressed format of this. So this one, I just want to, this is a step-by-step to show the relationship, okay, between the cubic form and the depressed form. So whenever in this case, whenever you get a cubic form, try to make it to the depressed, because all the rest of the solutions will be based on the depressed form. So we know, okay, so we know, I mean, for any, if the p and the q belong to the real, right? So how many roots are possible? What the possibilities of the roots of this cubic function? So we can have either Jonathan or Sam. What kind of roots possibilities if for the real coefficients? We can either have
2 imaginary or all real.
3 real, right? And the 2 imaginary are
real,
what?
2
2 complex are what?
Conjugate.
Yeah. Conjugate to complex CPX roots. Okay. So now let's find a root here. We want to derive, okay, 1 real roots, 1 real, okay, plus the 2 complex roots, okay. And what is the criteria to have such conditions? Okay, let's derive it. So the derivation is set t equals u plus v. Okay, now let's do it. So the t cube, so the first term is t cube, right? It will be the u cube plus the 3 of the u v square plus 3 u square v plus v cube. Is this the first term? The second term is the p of the u plus p of the v. The last term will be q, right? Okay, so when we sum them together, we can see we have the u of the cube plus v of the cube plus, right? So here is the 3uv u plus v, right? And here is the p of the u plus v. So we basically we have 3uv plus p u plus v plus q equals 0. Okay, because I mean from the one variable we use the two variable to represent that, right? We add 1 degree of the freedom, right? Once we add the 1 degree of the freedom, so we can reduce it by setting the 3uv equals negative p. Right. Once we set the 3u, what's the idea to set it? Because we can
cancel. It becomes 0.
We can cancel this term. So then we have the u of the cube plus the v of the cube, then plus the q equals to 0. Right? Okay, so now you guys think, okay? Now you guys need to think about it, okay? So we have the u of the cube plus v of the cube equals this, means u of the cube plus v of the cube is a negative q, right? How can we use, how about this one? This one tells me the uv equals negative p over 3, right? What if I say it's a u cube times v cube is a negative p over 3 of the cube? Does it ring your bell? Anybody? Jonathan or Sam?
X plus y is equal to something. No, vi does.
Vi does, yes. So Vaida tells us, I mean, that it is the, let's take the, which variable I want to use. How about, okay, let me use t, okay? So we have the t square, okay? Then this one is, so we have the minus of the, let me think, plus q of the t, right? Then minus p over 3 of the cube equals 0. Is this one equivalently t minus u cube t minus v cube equals 0? Yes or yes, right? Okay, so what's the next step? Sam or Jonathan, you think what should we do in the next step? Think about it, okay? Let me highlight what are we doing, okay? So the goal is we're trying to solve the real solutions of the t in this depressed cubic equation, right? We try to solve the t, and we set the t equals u plus v. And we try to figure out what is the u and what is the v in terms to solve the real solution, right? So now it comes to here. So now use the t. Can I use x?
You can solve the equation.
Yes. This is the x, right? Basically, we we're converting the cubic solution into a quadratic solution, quadratic equation, right? The quadratic equation, we can do the discriminant is a q of the square plus 4 of the p cube over 27. Then
Yeah, over 27.
yeah, we can write in the 4 of the q over 2 of the square plus p over 3 of the cube. Okay, now it's very standard, right? Now let's solve the x. So x1, 2 will be equal to 2a negative b plus minus 2 of the, I mean, let me say this is the 4 times delta 1, okay? So, right, do you agree with me? And it must satisfy the condition is delta 1 greater equal than 0. In essence is q over 2 of the square plus p over 3 of the cube should greater equal than 1. Do you guys agree with me so far?
Yeah.
Okay, no problem. Sam, how about you?
No problem.
Okay, then it's a negative q over 2 plus minus delta 1, right? So you can see we can set a new discriminant here. This will help us to know, okay, under this condition, if this condition is satisfied, if this condition is satisfied, okay, so this condition, the new discriminant in the cubic function, it will be q over 2 of the square plus p over 3 of the cube, okay, then this will be the two roots, right? So basically we can see the u cube is this, u cube is one of them, and the v cube is the second one. Okay, so in this condition, who can tell me, we're almost there, right? Who can tell me what is the, who can tell me what is the real roots? T equal what?
The cube root of negative q over 2 plus yeah, it's cube root of negative q over 2 plus delta 1. Then the same thing for b.
I think this is a very beautiful solutions. Okay, I think this is called the Candace running out of time. Yeah, Cantor's. Yeah, Cantor's.
I don't know, but
approach.
that
yeah.
that dude.
Yeah.
Yeah, he's picking a square or something.
Yeah. So let me okay. Let me finish the think about. I mean, if this is the real roots, right? So can anybody think about what is the other the pair of the imaginary roots?
Maybe the itos.
No, there are. This is the real, right?
Yeah, but
we could.
We know that the itos.
Vaidas? No.
Yeah. Since
how can we forge the other two complex roots also satisfy the same equation? Let me remind you, we need to satisfy this equation, okay?
Wait, maybe
we need to satisfy this equation. Okay, Sam, Jonathan, amazing part comes from here. Okay, did you see we solved the U and V?
Wait, delta could be negative. I mean, yeah, delta 1 could be negative.
Yes, but I'm saying here, we need the delta
could
to be positive
complex
here.
On the circle.
Okay, let's do it. Let me do something for you. Okay, How about I
Three
write
possible choices for U times 3 possible choices for V is 9.
What is this?
you think will this one satisfy this? Think about it. Can this one satisfy about this equation? If I times the phasor, right? This phasor to the cubic, does it apply? Does it really matter?
Well, it doesn't matter since if it becomes U cubed.
U cube. How about this? V is still V cube, right?
Same thing. It's the same thing.
Okay, how about you know the P plus 3 UV equals 0. How about the P times 3, P plus 3 of the UEI of the 180, 120 and the V of the 240?
Or we can just move, we can just become
Is this still 0?
P plus 3 UV. Yeah, since the EI 2 pi over 3 and
Okay.
EI 4 pi over 3 cancels.
So is this the first complex roots?
Yeah.
What's the second complex roots? You tell me, Sam or
Conjugate.
Jonathan. Conjugate, good,
conjugate.
great. So we can do this. Is this nice? I think it's very
Yeah.
nice. Yes. Okay, so Sam, we have to log out first and let's log in again. Is that okay?
Okay, sure.
Yeah, okay.